All right, let's dive in. We're about to run a simulation of one of the most powerful and honestly ingenious ways we generate electricity. We're going to see exactly how the incredible force of falling water gets turned into the power that lights up our world. Let's get started.
I mean, think about it. It seems almost impossible, right? How can something as simple as water flowing downhill have enough juice to power a hospital, or even just charge the phone that's probably in your hand right now? Well, that's the big question we're here to answer.
You know, the whole idea for this explainer came from a pretty direct request in our source material. They wanted to see a simulation, a proper breakdown of how a hydroelectric dam actually works. So that is exactly what we are going to do.
We're going to follow the energy on its entire journey, all the way from a calm lake to the electrical socket in your wall. Our simulation kicks off with the source of all this incredible power.
It all begins with a massive amount of water, a huge reservoir held back by a dam. You see, the sheer height and the unbelievable weight of all that water, well, that's the secret ingredient to everything that comes next.
So here's the game plan for our simulation, the whole process in just 4 key stages. You store it, you flow it, you spin something, and you send out the power. Let's tackle that first step, storing all that water.
Now there's some really cool physics going on here. All that water just sitting there way up high is absolutely brimming with something called potential energy. It's literally just energy waiting for its big moment, waiting for a chance to be used. And now, we give it that chance. This is the moment where all that quiet potential becomes a very loud, very powerful reality. The gates open and the water starts its incredible journey downward. The water doesn't just, spill over the top. No, it's channeled very precisely into this huge, downward-sloping pipe called a penstock. This thing focuses all that immense weight and pressure into one unstoppable stream.
And right here, this is the first huge energy transformation. As that water comes rocketing down the penstock, its potential energy, that stored energy of position, it instantly transforms into kinetic energy. And that's the raw, powerful energy of pure motion. This brings us to the very heart of the entire operation. All of that rushing, powerful water is now aimed squarely at one specific target, the machine that makes everything else possible.
So, we've turned potential energy into kinetic energy. We've got a torrent of water moving with almost unimaginable force. So what do we do with it? Well, the whole thing, it all boils down to this one simple, vital action.
That's it. All that incredible engineering, all of that raw, natural power is designed for one purpose: to make something spin. Here's how it happens. That water slams into the blades of a gigantic turbine, forcing it to rotate at an incredible speed. Think of it like a kid's pinwheel, except instead of a gentle breeze, it's getting hit by the force of an entire river. And just like that, the water's kinetic energy has been converted into mechanical energy. Okay, so we've successfully used the water's force to create this powerful, spinning motion. But a spinning turbine isn't electricity. So how do you make that leap? Well, this is where the real magic happens. So, we've got our mechanical energy from that spinning turbine. What we need is electrical energy, right? The flow of electrons. To make that happen, the turbine is connected directly to the next piece of the puzzle, the generator. Okay, check this out. This is so cool. Inside that generator, the turbine shaft is spinning a set of massive magnets right next to tightly wound coils of copper wire. As those powerful magnetic fields sweep past the wire, they literally get the electrons in the copper excited and force them to move. And a flow of moving electrons? Well, that's it. That's an electric current. We've just made electricity. So we have electricity. But hold on, our simulation isn't quite finished. The last part of this incredible journey is getting that power from the dam and out into the world where we can actually use it. First, the current we just made is sent to a transformer. You can think of this thing as kind of like an electrical pump. It massively boosts the voltage, and this high-voltage electricity can travel over power lines for really long distances much more efficiently. From that transformer, the electricity flows out into the grid. It travels across all those tall transmission towers you see, along wires that stretch for miles and miles, eventually reaching our towns, our homes, our communities. And so we come to the end of the line. We follow this energy from its calm, quiet, potential state all the way through a series of absolutely incredible transformations. And that's the whole
elegant process. Potential energy becomes kinetic, kinetic becomes mechanical, and mechanical energy finally becomes the electrical energy that is powering the very device you're watching this on right now. So, our simulation is complete. From a quiet reservoir to a bright light bulb. It really makes you wonder, doesn't it? What other incredible, invisible journeys are happening all around us every single second of every day just to make our modern world work?